Statistical inference can be explained as the process of arriving conclusion about the population from the sample. It is generally classified as estimation of parameters and testing of hypothesis. In this video, I will be introducing various methods of estimation of parameters. Estimation of parameters itself is divided into two categories: point estimation and interval estimation. I will explain this by using a simple example. Imagine about a large department store having multiple branches. Usually, these type of stores uses an integrated inventory management system. Suppose you as a member of an audit team assign the task of auditing the efficiency of the inventory management system. You want to find out the average demand of various commodities and the proportion of demand that could not be delivered because of insufficient stocks. One way to do this is that you can collect all invoices and review each and every invoice and the transactional records to find out the required parameters. Another approach is that you can use the statistical estimation procedures to estimate the required parameters. The statistical estimation procedure is as follows. Take a sample of invoices of the respective commodities. Compute the average demand and proportion of invoices that could not be delivered from the sample. These values, which are calculated from the sample, can be suggested as estimates of the population values. This procedure is called point estimation, and the statistics suggested are called point estimates. In the case of sampling from a normal population, it has been proved that sample mean and sample variance are the best point estimates for the population mean and population variance respectively. Another method that can be used is that instead of suggesting a single value as an estimate, we can suggest an interval within which a population value is like to lie with a specified probability. This procedure is called interval estimation. In interval estimation, the interval suggested is called confidence interval, and the probability that a confidence interval contains the true population value is called confidence coefficient. Confidence coefficient is usually expressed as percentage and is called confidence level. For example, a confidence interval with a confidence coefficient 0.95 is known as 95% confidence interval. Generally, confidence level is expressed in a format 1 minus alpha into 100%, where alpha is a number between 0 and 1. Thus, for a 95% confidence interval, alpha will be equal to 0.05. For a 99% confidence interval, alpha will be equal to 0.01. That means when alpha equal to 0.05, your 1 minus alpha becomes 0.95. That into 100% becomes 95%. Similarly, when alpha is 0.01, 1 minus alpha becomes 0.99 into 100% becomes 99%. In this video, we are considering only confidence interval for mean and confidence interval for proportion. First, let us take the case of mean. We have a general formula for finding 1 minus alpha into 100% confidence interval for mean. This is given by x bar minus b into sc to x bar plus b into sc. This means the lower limit is given by x bar minus b into sc and upper limit is given by x bar plus b into sc, where this b denote the critical value and sc denote the standard error. Both this critical value and standard error are to be decided based on the sampling distribution that we are going to use. Now, these are the various possible cases. If the population standard deviation is known to you, then the sampling distribution will be normal. Correspondingly, your critical value will be Z alpha by 2 and standard error will be sigma by root n. If sample size is large, means more than 30, in that case also, your sampling distribution will be normal. Hence, critical value will be Z alpha by 2 and standard error will be S by root n. In this case, population standard deviation is not known, but sample standard deviation is known. Now, if the sample size is small, the sampling distribution will be student's t distribution with n-1 degrees of freedom. Hence, critical value will be T alpha by 2 and standard error will be S by root n. Z alpha by 2 and T alpha by 2 can be calculated using the Excel formula given here. Z alpha by 2 equal to norm dot S dot INV 1 minus alpha by 2. T alpha by 2 is given by T dot INV 1 minus alpha by 2 comma n minus 1. So entering these Excel functions in Excel, you can calculate the critical values. Now, we will take an example. A real estate agent needs to estimate average value of a residential property of a given size in an area. The real estate agent believes that standard deviation of the property value is sigma equal to $5,500 and that property values are approximately normally distributed. A random sample of 16 units gave sample mean of $89,673.12. Find a 95% confidence interval for the average values of this kind. So here we have to find out a 95% confidence interval. From the problem, it is clear that you are given the population standard deviation. So the sampling distribution to be used is normal distribution only. Let us see the quantities given to us. Sample mean is given, population standard deviation is given, sample size is given as 16. Now the general formula is nothing but X bar plus or minus Z alpha by 2 into sigma by root n. Your critical value is Z alpha by 2 and standard error is sigma by root n. Alpha is given to be 0.05. You are asked to calculate 95% confidence interval. 95% confidence interval means your alpha value will be 0.05. Correspondingly, 1 minus alpha by 2 can be calculated and Z alpha by 2 can be obtained by using the Excel formula norm dot S dot INV, this 0.975. By entering this formula in Excel, you will get the critical value as 1.96. Now, we can substitute the various values in the general formula and get the required confidence interval. So substituting X bar equal to 89,673.12, Z alpha by 2 equal to 1.96, sigma equal to 5,500 and root n equal to 4, square root of 16, that will be 4. You will get lower limit as this value and upper limit as this value. Another example, digital media have recently begun to take over from print outlets. A newspaper owners association wants to estimate the average number of times a week people buy a newspaper on the street. A random sample of 100 people reveals that the sample average is 3.2 with a standard deviation 2.1. Construct a 99% confidence interval for the population average. So we need 99% confidence interval for the population average. Your sample size is hundreds. So clearly it is a large sample case. So you can use the sampling distribution as normal distribution. Let us take the quantities given to us. You are given sample mean equal to 3.2. Sample standard deviation is given to be 2.1. Then your sample size is n. We have the general formula with us. X bar plus or minus Z alpha by 2 into S by root n. Here, since we are using normal distribution as the sampling distribution, critical value will be Z alpha by 2. Standard error will be S divided by root n. Alpha is to be taken as 0.01 because you are asked to calculate 99% confidence interval. For 99% confidence interval, alpha will be 0.01. So you can calculate 1 minus alpha by 2. Z alpha by 2 can be obtained by the Excel formula norm.s.inb 0.995. You will get the value as equal to 2.576. Now we can substitute these values in the general formula. Substituting these values, we will get the result as, so this is your x bar 3.2, your Z alpha by 2 is 2.576, then standard deviation is 2.1, then root of n, that is 10, root of 100 equal to 10. Computing these, we will get the lower limit and upper limit as follows. Another example, a management consulting agency needs to estimate the average number of years of experience of executives in a given branch of management. A random sample of 28 executives gives a sample mean of 6.7 years and standard deviation 2.4 years. Find a 99% confidence interval for the average number of years of experience for all executives in this branch. Here, we are asked to calculate 99% confidence interval for the mean. Sample size is 28, so we have to go for small sample. Population standard deviation is not given. The given standard deviation is only sample standard deviation. Hence, we have to use student's t distribution. Let us see what are the quantities given to us. Sample mean is given to be 6.7. Sample standard deviation is given to be 2.4. Sample size is only 28. We have the general formula here, x bar plus or minus T alpha by 2 into S by root n. Here critical value is T alpha by 2 because we are using student's t distribution with n minus 1 degrees of freedom. Then standard error will be S by root n. Now alpha is given to be 0.01. Hence 1 minus alpha by 2 will be 0.995. Now we can calculate T alpha by 2 using the Excel function t.inv. You have to enter the 1 minus T alpha by 2 value and n minus 1. Here sample size is 28. Hence n minus 1 will be 27. Entering those values, you will get the critical value as 2.77. We can substitute these values in the general formula and get the values like this. We are simply substituting x bar as 6.7, T alpha by 2 as 2.77, and sample standard deviation S is equal to 2.4 divided by square root of the sample size, that is 28. Now, we can calculate it as lower limit, you will get it as equal to 5.4436 and upper limit will be 7.9564. Another example, the management of a supermarket needs to make estimates of the average daily demand for milk. The following data are available. Number of half-gallon containers sold per day. Data is given to you. Assuming this as a random sample, find out a 90% confidence interval for the daily demand of milk. So you have to find out 90% confidence interval. You are given the sample. Clearly, this sample is a small sample. So we have to consider the sampling distribution as t distribution. Now, using this sample, you can calculate sample mean and sample standard deviation. Here, the only difference is you are not given the sample mean and sample standard deviation. Instead of that, sample itself is given to you. So, you can use this data, you can enter the data in Excel, calculate sample mean and sample standard deviation and use the procedure adopted in previous cases. Next, we are coming to the confidence interval for proportion. The general formula is given by P minus Z alpha by 2 into square root of P into 1 minus P divided by N. This will be the lower limit. Upper limit is given by P plus Z alpha by 2 into root of P into 1 minus P by N, where this P denotes sample proportion. We are using normal distribution as the sampling distribution. Hence, the critical value is nothing but that is Z alpha by 2. We know Z alpha by 2 can be calculated using this Excel function. Let us take a simple example. A global WebEx study, as reported by TechCrunch, noted the percentage of adult internet users that owned various devices. Suppose that a survey of 1,000 adult internet users found that 910 adult users own a computer, 800 on a smartphone, 470 on a tablet, 90 on a smartwatch. For each of the 4 devices, construct 95% confidence interval for the population proportion for the adult internet users. Now, we can substitute these values in the general formula. Substituting these values, we will get the result as, so this is your X bar 3.2, your Z alpha by 2 is 2.576, then standard deviation is 2.1, then root of n, that is 10, root of 100 equal to 10. Computing these, we will get the lower limit and upper limit as follows. So, we are given 4 different devices: computer, smartphone, tablet, and smartwatch. You are asked to calculate the confidence interval for the proportion of all the 4 devices. Sample size is 1000. So, if you just take the case of computer, proportion is nothing but 910 divided by 1000. If you take the case of smartphone, the sample proportion will be 800 divided by 1000. Similarly, you can calculate proportion for the other devices too. I will illustrate the first 2 cases. So, let us take. We need the confidence interval for proportion. We have a general formula for that one. General formula is given by P minus Z alpha by 2 into root of P into 1 minus P divided by N. Similarly, the upper limit is given by Z. Let us see what are the quantities given to us. You are given sample size is equal to N. So, for the first case, that is for computers, your sample proportion will be P equal to 910 divided by 1000, that will be 0.91. Now, you can calculate Z alpha by 2. You are given alpha equal to 0.05 because you are asked to construct 95% confidence interval. For alpha equal to 0.05, previously we calculated Z alpha by 2 as 1.96. Now, you can substitute these values in this general formula and calculate the lower limit and upper limit. Substituting these values, you will get lower limit as equal to 0.8923 and upper limit as 0.9277. Next, let us take the case of smartphone. Here the only difference is proportion is 800 divided by 1000. 800 divided by 1000. You have to make the corresponding changes. Proportion will be 0.8. Corresponding changes can be made and you can substitute those values in the general formula. You will get it as equal to lower limit will be 0.8852. Upper limit will be 0.9348. I am not considering the other cases. You can do in a similar way. That's all about in this video. Thank you very much. Thank you for watching.